Part A here asks you to make a slope field for the given differential equation at the 12 points indicated. So it gives 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And in the exam, it would copy this so that you just have to sketch those locations at those points. So, let's see. Like I had said when we did slope fields, you can have a few different systems for doing this and for getting your equations. The way I'm going to do this first one is by saying, first of all, this doesn't exist when y is 0. That's why there's no points to graph here, because they don't exist. But it does exist, and I know some people miss this on the test, it does exist when x is 0. When x is 0, as long as y is not 0, then dy dx is going to be 0. So when it's 0, then our slopes look like horizontal lines. Right, as long as y is not 0. So any other value for y, dy dx is going to be 0. Next, let's talk about when x is 1. When x is 1, then dy dx equals negative 2 times 1, so negative 2 over, and then whatever our y-coordinate is. So negative 2 over our y-coordinate, and then we'll put in our different y-coordinates. So going down the line, this is going to be negative 2 over 2, which is negative 1. This is negative 2 over 1, which is negative 2. This is negative 2 over negative 1, which is going to be a positive 2. This is going to be negative 2 over negative 2, which is a positive 1. When x is negative 1, then dy dx is negative 2 times negative 1 is going to be a positive 2 over whatever the y-coordinate is. So that means we'll have positive 2 over whatever the y-coordinate is. So here's positive 2 over 2. Here's positive 2 over 1. Here's 2 over negative 1, so that's negative 2. Here's 2 over negative 2, which is negative 1. So there's what your slope field should look like. Part B, let y equals f of x be the particular solution to the differential equation with the initial condition f of 1 equals negative 1. So whenever you see that, that's a clue that we're about to do some separation of variables. In fact, that's what we're going to do in part C. In part C, it says find the particular solution given the initial condition f of 1 equals negative 1. So in other words, when it asks you to find a particular solution, that's the key phrase that we are looking at separation of variables. So here's dy dx. We know that f of 1 equals negative 1, so that means our point is 1, negative 1. So for part B, dy dx, well, we're going to see what dy dx is at 1, negative 1. We we've already done this because we made the slope field, but let's do it again. X is 1, y is -1, -2. So since that's dy dx, that's going to be our slope of our tangent line. It wants the equation of our tangent line. The equation of our tangent line, y minus your y coordinate equals the slope times x minus the x coordinate. Y minus the y coordinate, the y coordinate here is -1, equals the slope times x minus x coordinate here is 1. And what is our slope? Our slope was -2.
Isn't it positive 2? Negative over negative.
Oh, yes, sorry. This is +2. So this is going to be +2. Thank you, thank you. As I was saying, +2 for dy dx. So y minus a -1 is going to be y plus 1 equals our slope of 2 times x minus 1. And then it asks us to use it to approximate f of 1.1. So the idea is that, okay, since our slope is 2, our curve looks something like this at that point. Might look something like that. And so we're saying the slope of the tangent line is here. And so the idea is that when we are very close to the point that we have our tangent line at, then the tangent line is going to be very close to what our actual y coordinate ends up being on the graph, because the tangent line comes so close. So this won't be the exact y coordinate at that point, but it'll be very close to the y coordinate at that point. So let's do that. F of 1.1 means we want to take our tangent line and plug in 1.1. One minus 1 is 0.1 times 2 is 0.2. So there's our estimate. Here's our tangent line. So those are our kind of final answers to part B. Now for part C, here comes our separation of variables. Here comes the process that we've been doing over the last couple days. dy dx equals -2x over y. First thing we do in separation of variables is separate the variables. So we're going to multiply by y over here, then we're going to have a y dy, and then move the dx over to the other side, so we're going to have -2x dx. Now that we have the variables separated out, we're going to take the antiderivative on both sides. Antiderivative here is going to be 1/2 y squared. Antiderivative here is going to be -x squared plus c. So again, we can either solve from here for C, or we can work to get y by itself here first. I'm gonna get y by itself first. That's just the way I'm gonna prefer to do this one. First, we're gonna multiply by 2 on both sides, so we have negative 2x squared. If I double a number, it's still a number. Square root of both sides. We want a plus or minus there. And that's all underneath the square root. And now that y is by itself, we can plug in our point. What was our point? Our point was that if I plug in 1, I should get out -1. So -1 should equal plus or minus the square root. -2. This is what should happen when I plug in 1 for x. If I want a negative out, then this time I want the negative part of the square root. So the value of c that will make that happen is going to be a +3. So when you do that plus or minus in the square root, what determines whether it's the plus or the minus depends on what your output is supposed to be for y. This time we wanted y to be negative, so we want the negative square root here. And in our final answer, which is y equals negative square root of -2x squared. Our c was 3 plus 3. So that's our entire process. Most of that should have looked very familiar to you. We should be at the point where I would say the only thing you might have needed my help on was getting the approximation at 1.1 and how to do that. But otherwise, everything else we have gone over how to do. Here's the next question. And you should, we should be looking at doing this again. Part A is a slope field. Part B is a little bit different. See what you can do with it. Part C, find a particular solution. So it's asking you to do separation of variables. So I want you to take about 10-15 minutes and give this one a try. And we will look at the answer as well as take a look at how it was scored in just a few minutes here. All right, answer coming soon. I want to preface what you're about to see. Each free response question is worth a total of 9 points. They score it on a 9-point scale, and each part of the question is worth a certain number of points. So in this case, part A, the slope field is worth 2 points. Part B, this question is worth 1 point. Either you knew it or you didn't. and then part C was worth 6 points. So the entire part of this separation of variables, and it splits it into the steps. So there are spaces that even if you didn't identify the right parts or don't finish it all the way, you can still get part of the points for some pretty easy parts of the problem, actually. So let's take a look at that. Here we are. First off, here's your slope field for part A. For part B, looking at that slope field, where is it horizontal? It's horizontal at a y-coordinate of 1. So y equals 1. Where's your answer to part B? Right. Either you saw that or you didn't. All right, here is your separation of variables. So let me talk through the how first, and then I'll talk through the point values. First off, the how. They separate out the variables, took the antiderivative of both sides. Since there was a pi on front of here, to undo the chain rule, we needed a 1 over pi out in front. So that when the chain rule happened, the pi's would cancel and we'd still have the cosine without anything out in front. Over here, we needed a negative to counteract the negative 1 that would hop out in front for the y part. So this is your antiderivative step, the second step here. Then they are rewriting it a little bit. Instead of putting the negative, they basically took it, rewrote it on the bottom, and instead of writing y minus 1, they distributed the negative on the bottom and made it 1 minus y. You didn't need to do it that way. You can still solve for C the same way that we're about to show, even if you didn't do that. Now we're plugging in the point. So 1 over 1 minus 0 equals 1 over pi times sine of pi times 1. So sine of pi is 0, so C is 1. And so let's put the plus 1 there, and then solve for y. So that's the how part of the process. Point value wise, they give you a point for separating the variables. That's basically a free point to me for putting everything with y on one side and everything with x on the other side. 2 points for the antiderivatives. Probably 1 point apiece, unless you're really, really close on both of them. A point for putting plus c. If you put plus c, you've got a point. And then a point for plugging in and solving for c, a point for solving for y and getting the answer. Usually separation of variables is either 5 or 6 points, depending on how hard it is and what else they ask in the problem. And it's usually broken down in this way. You'll see this when we go over more of these questions on Monday. They'll give you points for separating out the variables, they'll give you points for taking the antiderivatives, and then getting your plus c, point for plugging in solving for c, point for solving for y. That's usually how the points are broken down there.